Hey folks, Quill18 here, and welcome to another video in our series of making a base building game in Unity, codenamed Project Porcupine. In the last couple episodes, we've gone and introduced inventory items that currently sit in stacks on the ground and don't do anything yet. And so in this episode, we are going to make them get used for something. Originally, I had thought that I might work on the stockpile system, but I realized there's actually a couple more questions to answer in the stockpile system, and it would be a little bit simpler if we just started with the construction side of it. In other words, when I build a wall over here, I want my little character to grab a stack of steel plates over here, which is what this is, and use them to build a wall. Maybe we need, I don't know, 5 of them or 10 of them or, some number like that. Let's say 5 for now, and we can, modify things later when we decide how much we want to produce metal plates, for example, right? But we want that to happen. So what happens right now when we tell our character to go and build a wall? Well, we create a job on the job queue. That job on the job queue is represented by this transparent green version of the graphic. Not a whole heck of a lot of fancy stuff going on there. And then our character simply walks to the location of the job tile, spends, I think we've got it in for like 0.1 second right now, just sitting idle doing the work. We could increase that to make it look a little bit more reasonable, but I had it at a short time just to test. And then at the end of the job, the furniture gets properly created, the job object is completely removed from the system, and we move on. So what we need to do is we need to add a little bit more information to our job to specify that, hey, this job needs a certain amount of materials. So let's take a look at our actual job class over here. So this is our job class. It holds all the information about the job we're about to do, including what tile the job is located in, how long it will take the job to complete. The job object type, I think, is just used for graphics. I should really have a comment about that. And then we've got a couple of callbacks here. These are functions that will be called if the job is declared to be complete, which happens when the job time reaches 0, or if the job is canceled, what might happen there, which is actually quite of an important thing. It wasn't as much of an issue before, but now that we are going to be bringing objects or inventory items to the job site, when the job gets canceled, those inventory items have to be treated in some sort of special way, because right now we have it. If we take a look at our tile class, if we look at our tile class over here, we have a spot here for inventory. The tile knows which inventory item is currently sitting in its own tile, and we have it set with the idea that really you only have one inventory item per tile. Or rather, it's more accurate to say the tile only points to a single inventory item. You could, through a variety of different reasons, decide that, you could have multiple pieces of inventory pointing to the same tile, or you could have them pointing to the same tile and a character. You could have them sitting in like limbo somewhere. Obviously, I mean, we don't, there's not a hard restriction. It's just like really the one restriction that implies one inventory stack per tile is simply the fact that the tile should probably know if it's got something in it, and we represent this by a single property as opposed to an array. And we're going to keep it there. But a wall, you could easily imagine a situation where you have a job item that needs 5 metal plates, 2 copper wires, a piece of fiberglass, some plastic, etc., etc. Multiple components to build an item. And where are those items, where are those inventory items going to sit? I mean, logically, from some of a conceptual point of view as a player, you imagine that they're just sitting on that tile right now until all the inventory items are assembled and construction can begin. But in our system, items that are being, or inventory items that are being assembled for a job will not belong to a tile. In fact, I would suggest that a tile pretty much needs to be empty of inventory items before you might build a piece of furniture on it, for example. So rather, it's going to be the job itself that is going to hold those inventory items. And then when it gets canceled, we're going to take all those inventory items and dump them. Most likely, we would put one on the tile where the job was supposed to be, and then scatter the rest in adjacent or nearby tiles until there's, we sort of run out of room. But we can look into that later on. But that's going to be part of the job canceling system. Is going to be, if any inventory items have already been brought here, let's make sure to properly scatter them and assign them to the tiles in a logical way. But that's going to be a little bit later on, probably not even this video. But what is going to be here this video is going to be some sort of dictionary where the key is a string, which is the, no. As I say, the key is the object, type or something like when we look at our inventory, we've got a object type ID. So the string of our job dictionary here, the string is going to be the same as the object type ID. And then the second part Well, what is it going to be? Is it going to be an integer to say how many we need? So this would be like job inventory requirements. Actually, I guess we don't have to have the job part. Requirements, because this is a job object, so we can just say something like inventory requirements. But then we need a second dictionary for what we actually have here. Alternatively, we could do something where these are inventory objects, right? Inventory instances of the inventory class. And we could set, in this version of the inventory class, we could set the max stack size to actually be equal to the requirements. So for example, this is not where we're going to do it, but for example, let's say in our inventory requirements, I mean, obviously, at some point, we need to make it a new dictionary, so that's probably a fine place to put it. And that might continue to be the case. But we can imagine something like inventory requirements. You set something for, like, steel plates. And we'll probably have a more centralized dictionary of these sorts of IDs. They might get replaced by enums or numeric code or something like that. I mean, I do generally like text strings for my object IDs, because it lets you do, like, stuff like maybe, you could do something like material, steel, and then, refined. And you can use it as ways to describe different stuff. And at some point, we will likely break object type from the sort of localized name of the object, right? So this may not be the string we actually show to the users at some point. Instead, we might end up having a lookup table where you've got, like, current language, and then the object type ID, and then the actual name for that object there. And you could have another lookup table for descriptions and so on and so forth. And that allows you to do localization later on, because you have just, one variable that shows your current language, and that's used to do your current lookup. So you can assume we've got something like language, and then you do something like en, and then material, steel, refined, and then you have something like name. And that will be where we store that. And then you can have a great little, some sort of file that contains all your name tags, which means it's easy to get, someone who's more competent at writing to rewrite your copy without having to do any change in your code. And when you do translations, you just make sure that there's more tables in there. So then you have the French version, etc., etc. So anyway, that is neither here nor there, but it's to anyone who doesn't like this object type being called steel plate. Yeah, I agree. We'll probably change it later, but for now, it's working awesome. So inventory requirement of steel plate. It's easy to say we could do something like new inventory. And come on, show me a little pop-up. Oh. All right, it just copies from another. All right, well, we'll do something like this. Inventory inv0 or something. Yeah, just inv is fine. New inventory. And then in inv, we do something like object type. So we're going to require steel plate, and I guess we need a space in there. And how many do we need? We need inv.max stack size. We set it to 5. And then if we assign that to our dictionary, and then later on, we keep checking to see is, this is later on in our code, if inv.stackSize is equal to inv.maxStackSize, we can begin our work. Something like that. And if not, then characters have to bring more steel plates to our target location. So that can work and might be better than having two numeric things, because we could, have inventory requirements int and then another one that is inventory delivered, but then we're not really keeping track of our stacks. I think it really does make a lot of sense to do this, to have these extra stacks with the stack size set to our requirements as opposed to what the actual max stack size of steel plates is, which is actually really good, because imagine you've got some other object type widget, which normally isn't stackable. The normal widget has a stack size of 1, but for our job, we need 3 widgets. So we actually do this. So a widget which is not normally stackable, we could do something of this nature. That might be a cool way of doing it. Well, we'll figure it out going forward, but I think for now, I think that's fine. We'll see if it works. We'll see if we get special cases where this doesn't cover us properly. And we'll just keep improving and iterating as we go forward. Okay, so I kind of like this. And right now we only have one type of job. So, you know, we could, for testing purposes, just go ahead and code this in. But I think we're going to go and make an improved job inventory requirement system as is. So in our world here, we have our furniture prototypes dictionary, right? So this is the platonic ideal, the original version of the prototype, of which all furniture gets copied from. And we currently create that in a function called create furniture prototype, which at some point in the future will be replaced by something that reads and parses XML files or something like that. But for now, is great over here. Now, we have to, these are the furniture prototypes. It would be nice, how do we know what a wall actually needs? Like our job over here, I can get rid of, I suppose, all of this. We might still want to instantiate a blank dictionary. That's probably fine. But our job at some point needs these inventory requirements passed to it. Which means we could, you know, pass something over here, which I guess is probably fine. Yeah, I guess that's probably okay. Sure. Let's get rid of this default value. We'll force people to specify a job time for each job, because obviously each job should take a different time. We have job time set to 0.1 by default, just for convenience, but we'll force that to be specified. And I guess what we'll do is just require this sort of dictionary here, and we will have to make a copy, because this is going to be... Yeah, I think we do have to make a copy. So this dot inventory requirements is equal to this dot copy duplicate. Oh, no, we can just instantiate. That's right. New dictionary, and you just copy it from the past inventory requirements. There we go. So now we've made a copy of the dictionary. Ooh, but it's not going to be a deep copy. I don't think this makes a deep copy. I assume this makes a shallow copy. It doesn't actually make a copy of the inventory objects itself. And we're going to be changing, right? At some point, we're going to be changing inventory requirements, steel plate, dot stack size. We're going to be setting it to a number, and we don't want this to modify that stack size for absolutely everything. So we need to do a deep copy of all this stuff, which is a bit awkward, but not too bad. Actually, what's interesting is we don't actually need this to be a list or a dictionary. We can actually have it be a list or even an array, which might have slightly less overhead. Inventory array of inventory requirements. Because what happens if you do it this way, what we can do is just create a blank dictionary. And we do, for this dictionary, we will want this to be, we'll want it to be an actual dictionary, not a list, because we want to be able to quickly find inventory of a particular object type. So we create an empty dictionary. Then what we do is something like, for each inventory in this inventory requirements, like the past inventory requirements, we set this dot inventory requirements. We create an entry in the dictionary based on the inv.object type, and we set it to be equal to inv.clone. So now we're making a clone of the actual inventory, of the inventory object itself, making a clone of it. That way, if we change stack size and all these things later on, it doesn't modify the one we're getting in from our prototypical job, which is exactly what this is here to do. All right, I think that's going to be a start. So now if we tried to compile this, we would certainly get some errors, because we, of course, are creating jobs, and we don't have the right job signature. Did I not actually? Hello, double click. What line is this? Oh, okay, I see, because we're creating a new job here, and then we're passing that. Oh, yeah, so it definitely needs a job time. So after that, we need a job time, which we'll continue to set at 1/10 of a second, and then it needs an inventory array of requirements. And some will be null. That's true. Some things don't need any materials, right? In which case the array should be null or an empty array. And I guess what we could do is just put in a check to see if it's null. If is not equal to null, then we go and try to populate this array. So now we should be back at a system that compiles and works, doesn't do anything differently. If we load and just try to tell it a job to go build a wall, that'll be fine because it's just getting past a null entry for the inventory requirements, and that's fine. So what I want to do, and yeah, we will have to make another change here because job needs, we need a clone function here, which is going to need another deep copy of stuff, but that's okay. So basically what I want to do is our furniture prototypes, I want these to also have a job prototype. Like we need these prototypes to carry information about how long does it take to build a wall and what materials are needed. Now, right now, the furniture prototype dictionary just has a reference to furniture itself. And I don't think that the furniture class, this furniture class, I don't know if this needs information about how to build itself. I don't think it needs that level of self-awareness, but rather there needs to be some dictionary somewhere that takes in something as the key. Now, this could be a string for the object type, or it could be a furniture instance where like the key is the furniture prototype itself. I think it makes more sense to use the string there. Because the problem with using furniture as the key is we have to remember that the key is actually the furniture from the prototypes array, not just any old instance. I mean, I suppose you could have, string is the way to go. And then we have some sort of job. And this is the furniture job prototypes. And this will probably be read from exactly the same XML file that contains the actual definition of the furniture. In the XML file, when we define the furniture, we also have a little block that says that, it's the job block for this furniture that says, here's the build time and here's the materials required. Now, we could include that as part of furniture, but I don't think every instance of furniture that's in the world needs that. I mean, I guess we could link back to a parent one. That's actually a possibility. Ooh, hold on. Yeah, well, each individual piece of furniture doesn't need to contain information about, float, my job time or something like that, or material requirement. But we could, say for this, just for now, for convenience, we'll make it public. We could have a job that is our job prototype, job construction job prototype, construction job prototype. And this could just be, when we make a copy of furniture, you can just copy this. It always point to the same thing. I guess that would be fine. And again, the individual instances of furniture may never use this. But that might be a fine way to organize it and stop us from having to create another dictionary. But I don't think, furniture itself, I don't think is ever going to use this. It's a handy little way to bookmark something that is sort of associated to furniture, but the furniture class doesn't need that. And so as a result, I'm not going to do it there. I'm going to go with this extra dictionary. I think that's going to be groovy and perfectly fine. So when we set up the world, so yeah, that's when we do create furniture prototype. Well, that's where we instantiate that dictionary. So we'll do the same thing with this dictionary. And again, when we're reading the XML file, at some point we're going to be populating this. But with our wall, we're going to go furniture job prototypes.add, and it's going to have the same furniture ID, and then it's going to also have a new job, and this is the prototype. And so it's going to need parameters passed to it. It doesn't have a tile yet, right? This is just the prototype. It does have a job object type, which we use for the visuals, so it's going to grab from the wall. It'll probably need some sort of callback. We're going to figure that out after, right? Let's just make a null for now. That's going to be okay. It's going to need the job time. And so for here, I'm going to overwrite the job time to like 1 second so we know it's working. And it'll need an array of of inventory requirements. So I'm actually going to go new inventory array, and it's just going to have one of it, which is going to be a new inventory. Right, which you create blank. There's not a, You can create an empty one. You can copy one. I think I want another constructor. Actually, where do we actually... hang on. Let's say I make this require an object type. Oh, no, I know where we create an empty one. It's when we're trying to read things in, right? This is probably in my world read code. Well, or in the code I just wrote. Yeah. That's perfectly fair. Document outline, create furniture prototype. Okay. So we'll leave the empty one in, which I think we need for our game loading and saving. But I make another one, public inventory, where you can specify a string for object type and an integer for max stack size and an integer for current stack size. Although we could probably safely have that default to actually 0. Just make a dummy stack. Yeah, you know what? We'll force people to specify something. That's okay. And we go this dot object type equals object type. And this dot max stack size is equal to max stack size. And this dot stack size is equal to stack size. Like so. There we go. So we'll force people to specify something if they want to do that. So now when we go back to the world, when we're creating this inventory, we got a version of it where we can specify stuff. Excellent. And this needs steel plate. And it needs 5 of them. And it starts with 0. There we go. So again, we're definitely going to want some sort of material lookup for these things to work a little bit differently or something like that. I mean, we're hard coding a lot of values, but this entire function is something that's going to be replaced with something explicitly not hard coded because we're going to be reading from a config file instead. And for the door, I'm not going to add a furniture job prototype because I want sort of an example of a piece of furniture that doesn't actually have its own job prototype. So I'm still going to want to use some sort of default dummy one and then throw an error. So I want to explicitly leave a case where we have a piece of furniture door with no furniture job prototype defined for it, and it's just going to have to figure itself out. What was this other one? Oh yeah, that was a callback. So right now, when we build a wall or anything, so this is our callback right here. This is the callback for when we finish a job on furniture placement. And we've got it coded inline in this function to do build. There's no reason why I couldn't have a static function. So public static void. We might want to put this somewhere else, but let me put it here for now. Job complete furniture building. You know, something of this nature, which is going to take a job called the job. And the contents of it is just going to be this over here. And luckily, the job has a reference to job object type. Yep. And the job also has a tile, which has a pending furniture job attached to it. So we can fix those over here. And so now, instead of defining a lambda on the fly, we can just say, hey, here's your job complete callback. It's that function there. And then for visual sake, we can probably go and do something more like this. Okay, so this works exactly the way that things were working before, and we can confirm that. First of all, we'll confirm that we compile okay, and we don't. Oh, yeah, just keep that null for now. We'll get right back to you. Okay, if I hit play and load, we should be able to build a wall over here. And on complete, so on complete, instead of calling a lambda function that we sort of designed on the fly here, or not here, right here. We used to just define an anonymous function. Well, now we actually have a function with a name. It does exactly what was going on before. And that's great. So it just gets past the job, and that's good. Now, what I'm going to do is basically do the same thing over here in our world, in our prototypes. So this needs a callback function. When the wall building job completes, what do we call? Well, we're going to call build mode controller dot job complete furniture building. I don't think this is where we want this. I think we want this function here to exist somewhere else. In fact, just like everything else, most likely this is going to be replaced with some sort of Lua functions in the future, right? So I guess really where it is we have a furniture actions static class, never gets instantiated. So I guess it actually makes a lot more sense to take this and move it in here. And this is all placeholder for stuff that will probably get replaced with some Lua stuff, or some of these may stay around in the future because it's convenient to have some C# versions of it. Now this will throw up 2 errors. Yes, no? Did I actually? Yeah, I was gonna say that should be in red. Come on. This can't run. What? Why are you not recompiling? There we go. Thank you. Gosh. I say this really should generate some errors. Because this function is no longer a function within the build mode controller class. Instead, we'll have to say furniture actions dot. Excellent. And that should not be the only error. Over here is the other one. This is in our world where we're calling that one. So furniture actions dot that. And there we go. So now we're good. Now, we're still not using this over here. Okay? But because our current build mode system just creates its own job over here. Do build. So we want to start using this furniture job prototype. So what we're going to do in our build mode controller, when we need to create a job for the furniture, what we're actually going to do is this. And we get an instance of world by doing this. If world controller dot world dot is furniture job probably not public, is it? It's not. Let's make it public. Maybe we want that to be the case for the future. Maybe we don't. I don't know. We made it public, so now we should be able to go dot furniture job prototype dot contains key. So, do you contain a key for this furniture type? If so, then our job that we're using is going to be equal to world controller dot instance dot world dot furniture prototype furniture type. So this is the correct job for this piece of furniture. Else, so this is if our furniture job prototypes don't contain this. What we're going to do is we're going to set the job to a dummy one. But we're going to put in a debug.log error just to remind ourselves that there is no job, or there's no furniture job prototype for furniture type. There you go. So we just log a little bit of an error, and then we give them a completely generic job that has no material components and has a build time of 0.1 seconds. And that's going to be fine. But now, I think our walls still won't take any material, but I believe they will take a second to build. Let's find out if we did that right. Load. And if I tell you to build a wall. Oh, nope. Argument cannot be null. Where is this? It's in the pathfinding system. What? Okay, so the only thing we've changed is where we get our job from, right? So let's say, like, you know, I grab the correct one here, but I'm going to override here with a second with our generic one. Let me try this. Load, wall. Okay. Oh, okay, first of all, we don't want to just grab it. We actually want to make a clone of the job, which we're not doing. But still. Oh! Yes! I understand. It's because our prototypical version of the job does not have a tile. The tile is set to null. Because when we create our job prototypes, we obviously don't know what tile the job is going to be in. So what we need to do, two things. Make a clone of the job prototype. Assign the correct tile. Because currently we're trying to pathfind to a null tile. That's exactly what's happening there. Okay, good. And what we don't have is the ability to do a job.clone, which obviously we're going to do. So we're going to create, it's going to be a virtual public job clone, and it's going to return a copy. It's going to create a new job that is copied from this. So we also need a protected copy constructor, which needs a job other, like that. And we are going to just copy all the stuff for this job, which is basically going to be these bits over here. Well, actually, I guess it's sort of going to be all this with those parameters passed. I wonder if it's good to call, well, I can't call this other constructor directly. Okay, so we're really duplicating a lot of work. We might want to come up with a cleaner thing later on in a refactor, but for here it's going to be okay. So, well, other doesn't have a tile, but I guess in case it does, we'll copy that. Really what we're doing is just copying null most of the time. Certainly the other's job object type, and we can just use literally the same array of callbacks over here. We can notice we actually don't do anything with the cancel ones, which I guess we should. Yeah, we don't even accept it. I think for now I'm just going to comment this out, just to make sure I don't accidentally use this somewhere and expect it to be working. So that's going to be okay. We're going to copy the other's job time and the inventory requirements. And again, we do have to make a deep clone of this. So we can say something like the other's inventory requirements dot values dot to array. We can't do to array. I think if we do using link, I think then it'll add a nice little to array on the other's values. Or I'm wrong. Can we just loop through this? Oh yeah, we do have job cancel references here. And cancel job gets called, but nothing, it never ever gets set. Alright, just, that's fine. Can I do this? Oh, is it system.link? System.link. We might not need it. Apparently we don't. Apparently you can just loop through these values as is, and everything is hunky-dory. Okay, well that's good to know. So again, as before, we're just going to loop through all of the values of the other's inventory requirements. We're going to make a clone of those. So we're basically making a deep clone of the other's dictionary, rather than just assigning the dictionary directly. So yes, it's very duplicatey over here, and there's probably a better way to do it. And maybe I'll look into that afterwards. But for now, that's going to be fine. So now we can actually clone jobs. So in our build mode controller, dot clone. That's good. And then the next thing we need to do is make sure that the tile is correctly set to T. So now, if we hit play, no, we don't hit play. Oh, really? Tile is, listen, just make the tile completely protected then. I'll try not to screw up and randomly set stuff. Load. And build wall. So this should take a second once we get there. And it does. It definitely does not go, like a door is still super fast. And it is. And in fact, we get the error that there's no job prototype for door. So it's creating a generic job that takes 0.1 second. So door, very fast. Wall, not fast because it's correctly using our job prototype. Okay, excellent. So we've got that system put in. What we're going to have to do is actually make use of materials, which we don't right now. We still go and, I guess I should probably pin this, dock that. We do go and say that it needs furniture, or that it needs steel plates, and we do copy that in the individual instance of the job that we're using to build this job and everything like that. So it should be fully aware that we need 5 steel plates right now. But what we need to update is the way our character deals with our job to actually pay attention to these requirements and go fetch those bits, which is not, an uncomplicated little thing, right? So this is our character's code over here, and somewhere in here, it's got update do job. So update do job. Do I have a job? Get the job. Find out if the job is reachable. Are we there yet? If we are there, so at this point, we are at the correct tile for our job. So execute the jobs do work, which is mostly going to count down job time and potentially call its job complete callback. Is going to be that. But there needs to be another step, right? So we have a job. We grab the new job. When we do have it, make sure that we can, to do, check to see if the job is reachable, which we don't do right now. That's not true. Well, okay, we don't check here. We may want to. We just blindly accept the job. But then what happens is on the next pass, we check to see if we can actually pathfind. So we set we have a destination, and on the next pass of update, we check to see, like, we have a destination, great, we don't have a path to it, we run a path here, and then at this point, if there's no path to destination, we abandon the job. So we might want to preemptively check to see if the job is reachable, but that's fine. But what we need here is we actually we can't set the destination to the job's actual tile right away. We have to do, like, to do. Does the job still need materials? If so, we need to go fetch them rather than just walk to the job site. Whoops. So then the question is, fetching these materials, is this part of the same job as the construction job? Or, and this is an interesting thing, what if a build job that gets put on a queue automatically spawns a job to fetch? Like, imagine there's a new job type called fetch, and it just requires a material and then a destination. We could certainly see, like, stockpiles maybe automatically generating these jobs or something of that nature. I don't know. I don't know if the get an item for a job should be an individual job or if it should be bundled in the same master job. The advantage of having it be its own separate job is that, let's say a particular building site needs 3 different materials. It needs, steel plates, copper wiring, and fiber optics. Well, it could spawn 3 different jobs for that, and you can have 3 different characters all doing the fetching for that sort of simultaneously. It might lead to weirdness, though, if they're all trying to get to the same tile at the same time. I mean, our characters can walk through each other right now, but it might look a little bit silly. And most games, most base building games, don't seem to do that. They seem to have, for any particular job, like furniture building job, they have one person that does all the fetching, and then once that person is completing the fetching, then the construction will then begin. Often by the same person, just because, it's all bundled in the same sort of construction task. Sometimes they'll get tired and need to go and, eat some food, and then someone else will take over. But it's basically the same as having, just abandon the job normally, right? So I think, for us, it probably makes sense if the person who has the job of constructing, say, the wall, this particular wall segment, that person is also responsible for hauling the goods over. Which means, to me, it's all part of the same task. So what we're going to want to do is rearrange this so that doing a job actually has 2 separate steps. Make sure all the materials are satisfied, and then once the materials are satisfied, walk to the final tile to do the construction. So that's what we're going to look at next time, is splitting this do job into probably literally 2 functions. It's probably the easiest way of doing it. So when do job starts, we check to see if we've got a job and that it's not null. And then once we've confirmed that we don't have a job, we do a little check there. Does the job have all the materials it wants? Yes. Then do this behavior, which is make sure you walk to the job site and then execute do work. And if it doesn't have all the materials it needs, instead we're going to check to see, we're going to find a piece of material somewhere, walk to it, have the character pick up the appropriate number from the ground, walk it over to the job site. So, and actually, I think we're going to break that down even more. Does the target job have everything that it needs? If not, is the character carrying the right amount? If not, go and pick some up. Because imagine, so our walls need 5 stacks of steel. What if we have a single stack of steel somewhere? So the character walks over to 1 stack of steel and should say, all right, I'm carrying 1 stack of steel. Is this enough to satisfy what the job needs? Because you could have the character walk to the wall with this 1 stack of steel, add it in, and then reevaluate if the materials are there, and then walk again. Or it might be better if the character walks over, picks up 1 stack of steel, and says, okay, 1 is not enough. I still need 4 more. Can I go and pick up 4 more? And then it walks over to another stack, grabs 4 more from there, and then it says, okay, I have 5. Great, that's what I need. Let's go deliver it to the job site. Repeat until all the items have been delivered, and then do the work. So we're going to work through that kind of AI sequence on in the next video. Thank you very much for watching another one, folks, and I'll see you next time. Thank you to everyone who pledged to support this project in March and is therefore funding these videos from April to early May, and especially these Mike Check supporters. A lot of familiar names: Wes Oldenboving, Craig Mortel, Neil Blakey, Milner, Speedy Savant, Valiant Cake Fiend, Aaron Toibson, Marius Fieldvold, Jan Torivel, maybe, I hope, Julien Auger-Lafont, Stephen Stager, Michael McClintock, Kale the Quick, Drazion, Bite Rash, Adjective, and absolutely everyone who just watches and favorites and likes and comments and has subscribed to the channel. You guys make this continue to happen, and I appreciate it so much. See you next time, folks.